Hi, I'm Zlatan Djenic. I'm a Senior Solutions Architect for Amazon Web Services, and today I'm going to show you how to run SQL always-on availability groups on top of Linux clustering. So let's get started. So let's first talk about all the options for deploying SQL Server on AWS. First, managed service option by running Amazon RDS for SQL Server means that we take care of everything. Means that we take care of scaling, high availability, database backups, DBMS patching, install and maintenance, as well as OS patching, and obviously everything hypervisor and below. We do also, high-level tuning tasks, schema optimizations, but it's really ideal if you want to don't have any in-house database expertise, you don't have any DBAs that can do this for you. Otherwise, what's common as well is running SQL Server on Amazon EC2. In fact, right now, if you go and type in Google Quick Start, first AWS Quick Start specifically, and first link that you get, or one of the first links, will actually take you to our Quick Start page, and there you can find our SQL Quick Start, which will actually deploy full-blown always-on availability group on Windows, right? And that means that you're going to be really responsible for scaling, high availability database backups, DBMS patching, install and maintenance, and OS patching. Having said that, a lot of it actually can be automated. A lot of this patching and administrative tasks can be automated by means of AWS System Manager. Rest of the things can be automated as well by means of hooking into events and perhaps using Lambda to execute certain tasks and automations and so on. If you went ahead and deployed SQL Server EC2 on AWS through Quick Start, this is what you're going to get. You're going to get effectively a 3-node, effectively it's a 2-node with the deployment of SQL Server always-on availability group with Active Directory. You have a choice of having Active Directory deployed as domain controllers on EC2 or using our, once again, managed service for Microsoft Active Directory. That's AWS Directory Services for managed Active Directory. There's a full-blown Active Directory you can use, and so you can actually, at least have that bit managed and provided, by us if you don't have or don't want the overhead of managing Active Directory in AWS. So, and then the third node being the file share node that as well as the witness that does the failover specifically for always on synchronous mode, right, with auto failover. This particular setup has also been a primary approach to us migrating workloads that use SQL Server specifically, and those that do support always-on availability groups. So we would effectively extend always-on availability group over to AWS from on-premise or between regions, and then you would have to also extend a domain and put in another domain controller, and that would also mean that WSFC cluster, Windows Server failover cluster, would need to be extended between on-premise and AWS, or between two different regions, for example, or anything that results in larger latency purely by means of the fact that it's just on that distance, right, on a different continent or something like that, or in a different facility. It could be a different cloud or anything like that. Coming back to it, this however has not. It's been successful in a lot of the cases, but in some cases, customers were complaining that they had to extend the Active Directory as well as the WSFC cluster and the whole thing. So thanks to Microsoft releasing SQL Server 2016 and 2017, we now have distributed availability groups, which means that you can have two separate clusters that are running in two separate environments, and they can replicate from one to another. And those can be on a separate domain, in a separate environment, in fact, on a separate OS in the case of SQL 2017. We still support failover cluster instances. You're more than welcome to use those. Back in the days, this was a common scenario, either with active nodes or active passive. The problem with failover cluster instances is that they only provide failover for the actual SQL nodes, not for the data. So should something happen to the data, or it gets corrupted, or it gets lost, that was the problem. So thankfully, in the past we would use something like log shipping or different storage replica solutions like Windows Server 2016 Storage Replica, or we have a lot of really great partners in this area like Sios Data Keeper Cluster Edition that provides both failover and data replication for failover cluster instances. So this is kind of a picture of how it all kind of comes together. I mentioned options of either managed service for always on availability, or rather for SQL Server, fully available, fully resilient, and fully managed rather. Also an option of deploying Active Directory or using our managed Active Directory service, and how that kind of works in the context of the rest of the AWS services, and takes advantage of, and applications that are using it can take advantage of things like external and internal load balancers, application load balancers, web application firewalls, our cloud fronts, our CDN distributions, DNS, auto-scaling services, and various other DevOps development and CDCI deployment services, as well as config, system manager, and other compliance services for encryption, and so on and so forth. Why do we choose and why do we want to actually deploy this on Linux? So I mentioned to you earlier that Microsoft has come up with SQL Server 2017. That specific SKU of SQL basically allowed SQL to be deployed on Linux. Great thing about SQL being deployed on Linux is that you don't have to worry about the cost of running a Windows operating system. It also that meant actually significant savings. It also meant that for any customer that had significant investment in open source could actually take advantage of that. Of that familiar environment, but it also provides a familiar environment for existing Windows users on how they can use SQL Server pretty much the same way they've used it before. It just runs on a different operating system, and in the case of always in availability groups, it runs on a different clustering technology. So in this case specifically, it uses Pacemaker, and we're going to go through an example of Ubuntu running SQL Server with Pacemaker, and then creating a Pacemaker cluster, as well as creating always on availability group, and then example of how we can fail over from one to another, and a whole thing. Another exciting thing is because of the distributed always on availability groups, we can actually have different clusters of different kinds replicating to one another. So we can have a always on availability group that runs on a WSFC cluster, and that replicates to another cluster that runs on top of Linux and takes advantage of Pacemaker clustering, right? And then those two can replicate between one another, making it basically compliant with running in hybrid scenarios and environments between Windows and Linux. And more importantly, you now have a third option as well of running, sending a AG cluster type to none that actually can replicate between one server to another, which actually means that the Linux can replicate Linux box or Linux SQL instance can replicate to another Linux SQL instance, but so can Windows Server SQL instance replicate to another Linux instance or a Windows instance itself, without the need of the cluster being configured. So that's very exciting. It gives us a lot of options, makes a lot of customers very happy, and makes a lot of things easier, especially when it comes to compliance with various teams on our customer side. So we're going to move on to the demo. So here we are in the console. We're going to go over to our EC2 console, and we're going to run some instances specifically. Let's go ahead and launch the ready-made AMIs with actual SQL Server. So if we actually go ahead and search it up here, you will see that we have Ubuntu Server with SQL Server Standard over here. So we're going to go select this guy over, and then we're going to choose an instance type that is commonly being used for SQL Server. So we're going to go with memory optimized, I guess R5 extra large is fine. And then we're going to go ahead, and here it's going to actually deploy the SQL Server in default VPC. Not something I would suggest, but for demo purposes, here we are. And to make things faster, we're going to say deploy 3 instances, because we're going to create a 3-node cluster over here to achieve full quorum, fully synchronous cluster. And then we're going to go over and we're going to specify what we want to use for storage. And we're going to say 500 gigs just to be on the safe side. And then we're going to go and add some tags. Specifically, when I add a name tag, so I can find it easily, and I'm going to call it SQL Linux AG Node 1. So I'm going to just call it a node, then we're going to give it a name afterwards. So it's just going to do this in triplicate for me. And here I can actually specify. So you see, this is kind of smart enough over here to figure out that I need MS SQL port open. I did create a security group prior to this. There are several ports that need to be open. So we're going to go over and we're going to select this security group, and I'll show you exactly what I got here. So as you can see, in addition to MS SQL open, I got this UDP port, TCP port, 5405, 2224, in addition obviously to SSH, 3121, 21064, and 5022. We're going to go on and review and launch this. And once it's launching, we need to select a key pair that we're going to be using. Acknowledge that this is going to be used as an access to our instances. And then we're going to take a look at our instances. So now they are being built. Now that we have these 3 SQL instances created, now we're going to go ahead and connect to it. So here it already created a connection string for us. We're going to go to, here we are, it's already in. And we're going to rename these guys quickly so we can tell them apart. It's going to be 1, 2, and 3. So right now, the way I deploy them, I just deployed them very quickly. They all deployed here in the same availability zone. Obviously, you will be deploying them in separate availability zones. And we're going to go quickly, and then the third and last instance is going to be in a third tab. So let's select this guy, go back to our bash, and here we are. So right now we are in 3 different instances over here logged in. So first things first, we don't need to actually do this. This is in case you do run a separate type of Ubuntu instance that might be running the firewall. Then you would actually go ahead and run these scripts to actually open up these specific ports. And these are the ports that I showed you early on that we have opened up in our security group, right? Once you're done opening up the ports, you need to reload the firewall, and then it would be fine. So we'll just set this thing up. The firewall is not running at this point, so that's fine. But just to show you how that actually runs over. And then you can also, alternatively, you can disable the firewall yourself, and it's quite easily. You just go sudo ufw disable, and then we're going to run a sudo apt-get update. Make sure that our instance is updated. Now, having said that, if you're using our AMIs, they're mostly up to date. We always run it just in case. And then we're going to go ahead and install Pacemaker. We're going to install Pacemaker packages, right? That's going to be our clustering technology for our SQL. So I'm going to say yes, and we're going to install Pacemaker on all 3 nodes. Now we're going to go on this one, and then third and last one. Okay, so while this is going, looks like it finished on the first one. 2 more to go, pretty much done. Great stuff. Now we're gonna set a password for our default user and on all 3 nodes, specifically for Pacemaker. So this is my test password. And you can make it obviously whatever you want. And whoop, it's successful on all of them. So it's going pretty quick. Now we need to actually enable and start our Pacemaker services. So we're going to actually run that once again on all of the nodes, and it looks like we were successful executing it on every single node. Note how quickly these things are happening, right? There are a lot of moving pieces, that's true, but they're fairly quick as well. And now the next thing is we're going to create a cluster. Bear in mind what I'm doing here in the scripts that I'm using, I'm actually destroying any existing cluster. So in case you have created a cluster before, this script is actually going to destroy the cluster in order to create a new one. So here we are. I don't have any. This is a brand new instance as you saw me create. So from our primary node, now we can actually go, first of all run cluster authentication for Pacemaker. And in this case, we actually need to look at the instances we created. So what we need to look at is our public DNS in this case, or DNS entries that we have assigned to our nodes, right? So obviously they don't have to be public. We wouldn't want them to be, but they happen to be in this particular case. So, so here we are. So this happens to be the password that I was using. So I just specify password and the cluster that I've created, and then I specify which servers need to be part of the cluster. So we're going to go ahead and select this, and we can run this on a primary cluster node, which I'm just going to be the first one. So they've been all authorized, which is great. And to make things quicker, we're gonna just pre-select these guys, and we're gonna run a setup for a cluster setup that we're gonna name AG1. Okay, so here we are. We're gonna run our cluster setup. Again, this can run on the primary node. And here we are. For our next thing, we're going to say, hey, start a cluster on all, and then enable it too. And you can see it enabled it for every single node, which is exactly what we wanted. So like I said, you can actually run it through. So next thing, we need to configure fencing. So basically, Pacemaker cluster vendors, they require Stoneth. This is, if you've worked with Pacemaker before, you would know, you would probably have some experience with it. It needs to be enabled, and the fencing device needs to be configured to support a cluster setup. So when the resource manager cannot determine the state of a node or resource, fencing is used to then bring the cluster to a known state again. And it's mainly there to kind of prevent data corruption and other things. So we're going to go ahead and run. Basically, we're gonna disable for this test purposes Stoneth, and it can just be run on the primary node. Normally in production you wouldn't disable it; you would make sure that it's enabled. We can also set our property cluster recheck interval specifically every 2 minutes. Once again, that's that also you can set on your primary mode, and then. If you already have an availability group resource managed by Pacemaker cluster, note that all distributions that use the latest available Pacemaker package introduce a behavior change for the start failure is fatal cluster setting when it's set to false. So there are some gotchas to just make sure set it to true and update your existing AG resource property, to like 60-second timeouts, failure timeouts, to check on that. So those are some of the options that you can have. We can actually go ahead and set that up. So we're going to stop the SQL Server on all 3 nodes first. And then what we're going to do is we're going to set the SA password to make sure I type this right. Okay. So now we can actually go ahead and start the server over here. So you can literally just go ahead and run it. So while it's running, we also want to be able to actually use our SQL tools. So we want to run some of the SQL statements as part of creating and setting up a password for Pacemaker, and how kind of Pacemaker is going to control what SQL does, and later on also for creating the actual always-on availability group and the whole thing. So. In order to do so, we will. There are a couple of steps around this, and this is also noted if you're running. This is not necessarily going to change anything, but this is if you, for example, are running an Ubuntu instance that does not have SQL installed on it. You can also go ahead and use that to install SQL. So this is some quick commands. To show you on how you can effectively install and run. So we're going to quickly do the same over here for the other nodes. And then we're going to run sudo apt-get update and installation. So the next thing we're going to do, once this is over, we need to install MS SQL Server High Availability. So we're going to let that work. And then in order to, like I said earlier, to execute those SQL commands, we will need to install MS SQL tools as well as SQL CMD tool that we're going to be using. So we're going to first run these get these GPG keys, and then we're going to curl this. We're going to register the Microsoft Ubuntu repository. Then we're going to go ahead and install the tools. And then we're gonna run an update just in case. So we're gonna repeat all of this for the other nodes in case we wanna run things from there too. Do we accept the license terms? Yes, we do. And then the last but not least, register repository over here, and then run the same. And then over here, what we didn't run this, another update, and MS SQL tools. Already installed, already newest version. We checked everything, made sure. Now we're gonna go ahead and from our primary node, we're gonna select, we're gonna connect to the local host. This is a common thing. Pay no heed. It's just where I'm copying from. It's copying the wrong inverted commas. And here we are. We are in our SQL CMD tool. In there, we're gonna go switch over to master. Here we are. And then we're gonna create a login for Pacemaker. Then an Alta server role to add it. Once that is done, we can actually exit. So we're gonna go ahead and create the credentials and have them saved, both the which will be only readable by root. So then we're gonna go ahead and create the AG resource, availability group resource. We already created it. That's a good error we got. And then we need to set what virtual IP that is going to be used. So we need to make sure that this is an unused IP specifically. So looking at what IPs we have available, I want to use a private IP. I guess 120 is not the used one. So let's see here. So make sure when you do create a virtual IP, there's the IP that is available and it's unused specifically. Then we can add co-location constraints. Almost every decision in a Pacemaker cluster, like choosing where a resource should run, is done by comparing scores. So scores are calculated per resource, and the cluster resource manager chooses the node with the highest score for a particular resource. So if a node has a negative score for a resource, the resource cannot run on that node. Use constraints to configure the decision of the cluster. Constraints have a score. So if constraint has a lower score than the infinity, it is only a recommendation. So we're gonna go ahead and set the co-location. So to ensure that primary replica and the virtual IP resource are on the same host, we're gonna define a co-location constraint with a score infinity. So here we are. And then we can also add a ordering constraint. So the co-location constraint has an implicit ordering constraint. It moves the virtual IP resource before it moves the availability group resource. So by default, the sequence of events is the user issues APCS resource move, the virtual IP resource stops the node 1, and then it starts the node 2, and then the primary node 1 gets demoted, and then node 2 gets promoted. So we now going to create an ordering constraint specifically for this virtual IP. And this has actually set up our cluster completely. Now we have a fully working cluster that we can now manage. And obviously, there are constraints that we have set up on how this cluster is going to fail over, but that also doesn't stop us from manually failing over. So we can go ahead and let's say we want to fail over to node 2. We can then select that. Over here, I want to replace and replace the value for node 2. And then we're going to select it over here and run it. And this will actually go ahead and start switching the resource and demoting the primary node to the secondary and promoting the second node to the primary one. And this will also instruct the always on availability group to actually start switching over. And that's one of the things that I want to go back to my slide deck. I wanted to talk to you about what to do next. We need to first create a certificate that is going to be used, and then we need to create the certificate on secondary servers as well that are going to be used. Once the certificates are created, then we need to create a database mirroring endpoints on all replicas. So these are going to be basic endpoints in what ports they're going to be listening to on each and every replica within it. And then once that is done, once we have the listening points, once we do have certificates in place, we can create an availability group. And now we have a fully blown availability group that actually synchronously replicates data between each node. Once that is done, then we can create a database and then add it to the availability group that we have. The next step really would be just to check, run a select statement to check if the actual database has been replicated to other replicas and run it against it. Once that is done, you basically have a fully synchronous 3-node cluster that runs across full-blown Pacemaker cluster that we just configured and got it to work with SQL specifically, which will fail over based on score and based on constraints that we have defined, as well as we will be able to manage it and manually fail over if necessary for whatever reason. By now, you should know how to run SQL always on availability groups on Linux clusters. Try it for yourself. Thank you for watching.